Do you want to learn how to use 3D Pokemon models in Blender? Do you desire to create an awesome wallpaper or profile picture featuring your favorite Pokemon? If so, then this video is for you. Hello everyone, glad to have you here. Today, I'm going to show you how to import, pose, and render Pokemon models using Blender. And by doing so, I hope to give you a better understanding of how these models work and how you can use them for your own projects. Before we get started, I want to put a few disclaimers out there. First, what you'll see in this video will be how I personally go about creating these renders, and what I do may differ from other professionals in the field of 3D graphics. So do not take these videos' instructions as an absolute. Rather, take them as a general guideline and compare them to other artists and your own experience to come up with a workflow that works best for you. Second, this video will not serve as a substitute as a complete beginner's guide to Blender. While I will be covering the general gist of how things work as we go along, I highly recommend that you turn to other videos in order to gain a better grasp of how to navigate Blender and its features. There's a lot of great beginner tutorials on Blender that can explain things much better than I can, and in the description below, I'll link a playlist to Blender's official fundamentals guide, so be sure to check that out if you're having trouble navigating the software. And third, while a lot of what I say about one Pokemon model will apply to a lot of others, keep in mind that it is not possible for me to cover every Pokemon model individually, and that there may be some unique quirks with one or two particular models that I don't know about. If you have any questions about a particular model, feel free to ask me in the comments below, or present the question in my Discord server. With that out of the way, let's get started. First, we're going to need to download Blender. Go to your search engine and type in blender.org. This will bring us directly to the homepage of Blender's website. And from there, we can press this big blue button to download the latest version of Blender, which at the time of this video is Blender 2.91. Blender is absolutely free to use, so no need to worry about pulling out a paycheck. Once Blender is downloaded, we're going to want to get our Pokemon models, and the best place to do that is a website called the Models Resource. So type the Models Resource into your search bar and click the following link. The homepage should look something like this, and from here, we can search for particular video games and their models by their home console. As you might expect, the widest selection of main series Pokemon games can be found under the 3DS section. But should you want a Gen 8 Pokemon, you may want to go to the Nintendo Switch section so you can see what models Sword and Shield has to offer. For right now, we're going to select 3DS. As you can see, Pokemon X and Y and Pokemon Sun and Moon appear on this page by default. And while you're likely going to be using models from these two games, particularly X and Y, I'm going to navigate a bit further just to show you how you can find the other Pokemon games. Near the top of the page, you'll see this row of letters. Clicking one of these letters will let you search for games alphabetically, so let's select the letter P. This will let us see a wider selection of games, including Omega Ruby and Alpha Sapphire, as well as Ultra Sun and Ultra Moon. Should you want models from one of those games, this is where you'll go. However, for the time being, I'm going to select X and Y, as they have by far the biggest collection of Pokemon models. Upon entering the page, each Pokemon will be listed by generation and the order they appear in the Pokédex, so use that to find the model you want. Not all Pokemon are available for download right now, but we still have a very wide selection to choose from. Today, I'm going to be using Eevee, because I suspect Eevee is a Pokemon that a lot of you will want to use, and it serves as a pretty good template for what we're going to be doing in Blender. So let's select Eevee from this list. This will bring us to another page, and from here, all we need to do is click the picture of Eevee, and the model will be downloaded to our computer. I'm going to take our downloaded Eevee folder and move it to the desktop. After that, I'm going to create a new folder on our desktop and call it Pokemon Models. This will be used to house our Eevee model, as well as any other future models we download. Inside the Pokemon Models folder, I'm going to create another folder called Gen 1 and move our Eevee folder inside of it, since it's a Generation 1 Pokemon. It's important to create a cohesive folder structure now so you can easily find and reference your Pokemon models in the future. Your models don't necessarily have to be structured by generation like I do, but your models should be arranged in a way that makes sense, be it alphabetically, generation, or otherwise. You will also want to try to avoid moving your Pokemon folders and their contents once you have imported the model into Blender, as doing so can make it harder for Blender to find it and cause some small graphical errors. But with that, our preparation is complete. So let's open Blender and get to working with our Eevee. Welcome to the wonderful world of Blender. Before anything else, I want to introduce some basic controls. First, we can select objects in our scene by left-clicking them. Next, by holding down the middle mouse button, or the scroll wheel, we can pivot around the scene like so. Rolling the scroll wheel up and down will also allow us to zoom in and out. And by holding down the shift key and middle mouse, we can shift our view in a particular direction. Once again, I highly recommend that you check out those fundamentals tutorials that I linked in the description, as those will give you a much broader understanding of how to navigate Blender and its various features. But anyways, let's talk about Mr. Cube here. We don't want to render a cube today, we want to render an Eevee. So let's select the cube and press the X key to delete it. Now that Mr. Cube is gone, let's bring Eevee in here. To do so, let's go up here to File, Import, collada-default.dae. This will bring us to a file selection menu, and from here, we can navigate our computer's files to find our Pokémon model. We put our Pokémon models folder on the desktop, so let's go to our desktop. Then we'll select our Pokémon models folder, Gen 1, Eevee, and then in the Eevee folder, you will see this file that ends with .dae. This is the file we're going to want to import. Before you import though, you'll want to come over to this box called Armature Options and enable these 3 buttons. This is incredibly important. Do not import your model until these 3 buttons are pressed. If you don't, the bones on your model's armature are going to be disconnected, incredibly small, and in general just incredibly annoying to deal with. So write this down, friends. With that said, let's import our model by pressing this import button. We should now see an Eevee in the middle of our scene, just hanging out, not really doing much. Depending on the Pokemon model you're using, the importing process may require a few more steps, as there might be some small bugs or issues that you'll need to work out. I will show you how to get through some of the most common issues at the end of this video, but for now, let's get a closer look at Eevee. By going to View, Frame Selected, Blender will zoom in on our selected object, which at the moment is Eevee, and set our pivot point around it. If you have a numpad on your keyboard, pressing the dot key on it will have the same effect. Upon closer inspection, it looks like our Eevee is encased in metal, like it picked up a metal box from Smash Bros or something. Luckily, it's easy to change this. If we go up to the top right, we'll see these 4 sphere icons. These are our viewport shaders, and by selecting them, we can change the appearance of our objects. By selecting this sphere here, we can enable material shading, which will allow us to see our Eevee's textures. Eevee still seems a little metallic though, so let's fix that. Go down and select this icon here to enter the materials properties. Inside, you'll see some named spheres inside a box. These are the model's materials, and each of these will dictate what a particular part of the model looks like. Scrolling down a bit will let us see some of the values we can change for our materials. There's a lot, yes, but we only need to worry about one at the moment, and that's the metallic bar. If you set that value to 0, you'll notice that the main part of Eevee's body isn't metallic anymore, but the mouth and eyes still are. That is because the material that is currently selected, material 12, is the one that dictates the appearance of Eevee's main body. We will probably want to give that material a more recognizable name, so double-click material 12 and rename it accordingly. I'm just going to call it Eevee Body Matte. Now let's do the same to the other 2 materials. Select them one at a time, and repeat the process like so. Remember to give each material an appropriate name based on which part of the model it alters. And just like that, we saved Eevee from its metallic nightmare. However, it's still looking a little bit shiny, so let's go back to our body material and see what we can do. This shiny appearance is the result of specular, and we can alter it using the specular and roughness bars seen here. Raising and lowering the specular value will increase or decrease the brightness of the highlights, while raising and lowering the roughness value will make the model more or less reflective. I recommend you mess around with these values to fit the Pokemon you're using, but for a Pokemon like Eevee, I like to turn the roughness to something like 0.9, while lowering the specular slightly. Let's do the same for the other 2 materials as well. All this said, it's important to note that the materials on your model may have different labels or default values depending on the Pokemon you're using. Again, just mess around with each of these materials to identify which materials correspond to which part of the model, name them accordingly, and then adjust them to your liking. Anyway, our Eevee's looking nice and healthy now, so we should take this opportunity to save our progress. Go up to File, and then click Save. This will bring you back to the File menu, where you can choose a location to save your .blend file, which are the files that Blender will use to contain your project. Feel free to save your file wherever you want, as long as you can easily find it later. For now, I'm just going to go to the desktop, create a new folder called Blend Files, and enter it in order to specify that this is the location that I want to save my blend file in. After that, I'll then go down here and name the .blend file itself. Once you're finished, click Save .blend file, and you're done. From here on out, you can simply hold Ctrl and then press S to save your progress instantly. I recommend you do this a lot. And creating backups using Save a Copy and Save As probably isn't a bad idea either. All's looking good. Let's get Eevee positioned for a render. And for that, we're going to need our camera, which is right here. This camera object can be moved or rotated to specify how we want our final shot to be positioned. Basically, what the camera sees is how everything is going to be arranged in our final image. But what is the camera seeing? Well, in order to see that, we need to first create a new window. Let's put our mouse between these two windows, right-click, and then press vertical split. This line will start following your mouse. Bring it to the center of the viewport and left-click. Now you have two 3D viewports, and you can position them separately of each other. We're going to want to use this new window as a camera view though. So let's go to this Windows View tab, and then select Cameras, Active Camera. Now we can see what our camera is seeing, and should we select our camera in the left window and press the G key to move it around, you will see that the right view follows the movement of our camera, which is pretty nice. Note that pivoting your view in the camera window will take you out of the camera view, so be careful about that. Now we could position this camera manually with a G key, but I have a more precise way of doing so. Let's click this small arrow on the right and pull out this panel. This panel will show us the exact location, rotation, and scale values for our selected object, and by adjusting these values, we can change our object's position in space. X is left and right, Y is back and forth, and Z is up and down. I'm going to hold down the left mouse button and scroll over these location values to select them all, and then I'm going to set their value to 0. This will put the camera dead center in our scene. I'm also going to set the X rotation value to 90 so the camera is tilted parallel to the ground, and the X rotation to 0 so the camera is facing Eevee dead on. With that done, I'm going to go up to our toolbar here and click this arrow button to enable movable arrows on our object. These arrows correspond to the X, Y, and Z axis, with red being X, green being Y, and blue being Z. And if we were to grab and drag one of these arrows, we would move our object along that specific axis. So I'm going to grab this green Y-axis arrow and pull our camera away from Eevee. I'm also going to use this blue Z-axis arrow to pull our camera off the ground a little bit. Let's take a few moments to look at our camera settings over here. We can use this focal length bar to zoom our camera in and out, which can be useful to alter the perceived distance between our subject and the background. I'm going to set our focal length to 125 for this render. Let's also check out our output settings by clicking this button here. Under Dimensions, you can change the pixel resolution of our final image. 920 by 1080 is a full HD image, and is good for many things, like wallpapers, videos, etc. But if you wanted to, say, make a profile picture for a social media account, you could set the resolution to something small, like 300 by 300, which will give you a smaller render, as well as a more box-shaped camera, since the camera aspect ratio is now 1:1. We're going to focus on making a standard HD image though, so I'm going to press Ctrl Z a few times to undo and get our original resolution back. With our image resolution and focal length in place, let's continue positioning our camera to our liking. This seems good. So how about we get to actually posing Eevee itself, because right now it's just kind of been giving us this weird blank stare. Select the weird metal sticks coming out of Eevee's ear, and frame our view on the selected object. These gray sticks are actually a part of Eevee's armature, which is an object that allows us to move specific parts of a model. Think of it as the model's skeleton. By altering this structure, we can move various parts of Eevee's body. Before we move anything though, let's go to our object settings and rename our armature object appropriately. Then let's go to the armature settings and do the same thing. Here in the armature settings, you'll also see a tab called Viewport Display. Open that and enable the In Front option. This will allow you to see the armature in full, which will make it a lot easier to work with. You can also change the appearance of the bones under Display As. Use whatever feels right to you, but I'm personally going to use the B-bone display. I'm also going to go up here and disable the overlays on our camera view. That way we can see how our model looks to the camera without the bones getting in the way. But anyway, enough delays. Let's get to posing this thing. With our armature still selected, go up here where it says Object Mode, and change the button to Pose Mode. Doing this will allow you to select each of these bones individually, and if we press the R key, we can rotate them from our point of view. That can be a little weird to work with though. So let's go over here and enable rotation lines on our object. Now by clicking and dragging on these multicolored lines, we can rotate our bone along a specific axis. We can also rotate along a specific axis by pressing the R key, followed by either the X, Y, or Z key, with each key corresponding to its specific axis. And with that, my friend, we have just opened up a whole world of possibilities. So how about we play around with the armature a little bit? Well, this is a mess. Not to worry though. If you find your Pokemon in a weird tangle like this, all you need to do is press A to select all of the model's bones, and then go up here to Pose, Clear Transformation, All. Bam! Eevee's back to its default, normal pose. The little guy's a lot more flexible than I thought, but for all of our sakes, it's probably best that they don't do whatever this is. Let's pose them for real this time, starting with the front legs. I'm going to take these top shoulder bones, rotate them inward a bit, and then rotate them slightly on the Z-axis. If you want to get a more direct view of the model, say from the front, just go up to View, Viewport, and then select Front. This will help me see where Eevee's front legs are in relation to the ground. However, our camera is a bit in the way right now, so I'm going to go up here in the outliner and click this little eyeball icon to disable it from our view for the time being. The camera's still there, but we just can't see it right now, which will help us get a clearer view of the model. Now I'm going to simply rotate the hand bones so they're relatively parallel with the ground, as well as make a few more small adjustments from there. Stop! It's important to note that some of these models have something called end bones at the end of some of their bone chains, which is something you might accidentally select from time to time. They don't really do much, so try not to pay them much mind. I will show you how to deal with them in a future tutorial on optimizing your Pokemon's rig, but for now, if you accidentally select one, just press the H key to hide it from your view. You can see which bone you currently have selected by looking up here in the top left corner. Eevee's starting to look pretty fancy, wouldn't you say? Let's move on to the back legs. I'm going to toggle into a back view and continue my positioning from there. These bones can be a little bit confusing to identify at times, but if you ever find yourself confused on which bone you currently have selected, remember, you can always look in the top left corner and the name of said bone shall be listed there. I'm going to once again push these legs in a bit and then rotate them slightly on the Z-axis. These legs appear to be hovering slightly above the ground, so I'm going to select one of the leg bones, hold down Shift, and then select the other one. This will allow me to select and adjust both of these bones at the same time. From here, I'll just rotate the feet so they're lined up with the ground. Next, I'll rotate Eevee's neck and head so that it looks like it's staring off into the distance. Maybe even give it a little head tilt, just to add a little bit more personality. Let's rotate the spine a bit as well. Some models actually have a few small deformation bones hidden at the end of some bone chains, like the second spine bone for Eevee, so keep an eye out for those. I will also cover how to make these bones more convenient to use in my optimizing Pokemon rigs tutorial, so look forward to that. Now, I'm going to share a little trick with you. If you go to this button right here, and change the object's pivot points to individual origins, you'll be able to rotate multiple bones in the same chain at once, like this. Use this to your advantage when positioning things like ears or tails. Speaking of tails, let's finish off by posing just that. Looking pretty good if I do say so myself. Though I probably want to adjust the camera just a bit more, so I'm going to turn it back on in the outliner and move it around until I think it feels right. Alright, so Eevee is all nice and posed now, just hanging out, staring into space, probably thinking about its favorite treat. But anyway, we should probably focus on adding a background. Go up to Add, Mesh, Plane to add a flat plane in the center of your scene. With that plane selected, press the S key to adjust its size and scale it until the left and right edges can't be seen on the camera. Eevee now has a floor to stand on, but that gray background is a little bit out of place. So let's make our plane cover that too. With our plane still selected, go back to the Object Mode button and enter Edit Mode. This is a mode that allows you to adjust the individual vertices, edges, and faces that make up a model, and we're going to use it to adjust our plane's shape. Select this vertex in the back, and then shift select this other back vertex. After that, press the E key on your keyboard to extrude a new face out of them. Press the Z key to lock this new face on the Z axis, pull it up, and left click to confirm its positioning. This deals with the weird gray background, but there's still a seam between the wall and the floor. So let's click this button to enable edge selecting, select this edge here, and then hit Ctrl B to bevel it. Scroll your mouse wheel to give the bevel more edges, and bam! That weird seam has been vanquished. Just for good measure, I'm also going to hop back into Object Mode, right click, and set our plane's shading to smooth. Our background is in place and things are looking up. Let's go to our camera view and enable rendered shading. This will allow us to view our scene as it will appear in our final render. And as you can tell, things are already a lot darker than they were using the material shading. No worries, we'll address this, but first we should probably take a moment to talk about render engines. If we go to our render preferences, we can toggle between 3 different render engines. Eevee, yes, that is the actual name and it's amazing, Workbench, and Cycles. Typically, Eevee is good at rendering things quickly, while Cycles allows more detailed lighting setups, but at the cost of longer and heavier render times. I don't really know what Workbench does. The engine you'll want to use depends on your personal preference and the amount of processing power you have, but for this tutorial, I'm going to use Cycles. I know, not rendering Eevee in the Eevee engine probably sounds like blasphemy, but I want to show you guys the best Eevee render I can, okay? Regardless, I recommend you experiment with both engines to see which one works the best for you. As soon as we switch to Cycles, you may notice something strange about Eevee. A lot of the shadows on its face are really jagged and not very appealing to look at. This mainly has to do with the model's polygon count in combination with how Cycles handles lighting. Luckily, there's a way we can fix this. First, you'll want to select the Eevee model, and then press the Tab key to enter Edit Mode. Similar to the plane, this will allow us to edit and alter Eevee's polygons. However, I don't recommend messing around here too much unless you really know what you're doing, because it can be very hard to fix a topology mistake once it's been made. Instead, I recommend you press the A key to select all of Eevee's faces, go up to the Face tab, and then select Tries to Quads. Immediately after you do this, go down to the box here and enable Compare UVs. Very important. This box will disappear once you click somewhere else, and if Compare UVs isn't enabled, you'll be stuck with some texture glitches, so make sure you click this immediately after pressing Tries to Quads. Anyway, converting the model's tri-faces into quad faces will help us in our next step. Tab out of Edit Mode, the scary part's over now, and go into the Modifier properties. From here, click Add Modifier and select Subdivision Surface. Using this modifier will smooth the model's features and get rid of those jagged shadows. That said, this will also smooth out more of the model's jagged features, like Eevee's hair, and this could present a problem on Pokémon with a lot of sharp edges, like Jolteon for example. I don't think the smoothing is going to be that big of a problem for Eevee though, so we'll keep the modifier applied as is. It's also important to note that enabling a subsurf modifier will use more processing power, so you may want to disable it from view in your viewport by pressing this button here. Alright, we're almost done. Just a few more steps left to go. One of which is lighting. Remember this black dot from earlier? Well, this is our lamp, and by moving it around, we can adjust where the lighting in our scene is. What you want to do with your lighting is largely up to you, but I'm going to do some basic studio lighting today. I'm going to move this lamp somewhere off to the side here, and give it a name in the object properties. I'll just call it Key Light. Now go down to the lamp settings, repeat my given name up here, and take a look at the settings we have to work with for our lamp. First off, 1024 light bounces is way too much for what we're going to need, so I'm going to set this down to 2, maybe even 1. Next, I'm going to adjust the radius of the lamp a bit. Lower radius values will often result in harsher lights and shadows, while higher values will result in softer lights and shadows. Since I want something a bit soft, I'm going to set this to 2. Next is our lamp's power, or how much light it emits. Finding the right value for this may require some experimentation with both it and your lamp's positioning, but in the end, I went with a value of 3500. Looking good so far, but I'll probably want to adjust the dark side of Eevee as well. It may be of note that you can go into the world settings and adjust the strength bar to create more ambient light, but I don't want this to play a factor in my render, so I'm going to set this value to 0. You may want to use it, but I'm going to pass on it for today. The shadows may be darker now, but not for long. I'm going to select my lamp and press Shift D to duplicate it. I'll then snap it back into its original place with right click, drag it to the other side of my scene, make some small position adjustments, and rename the light to Fill Light. Since this light is here mainly to dictate how dark the dark side of Eevee's body is, I'm going to disable Cast Shadow, just so we don't have two shadows going in opposite directions. I'll then lower the power of the lamp considerably, and play around until I get a look that I like. And just like that, we're pretty much done with all the hard stuff. We now have a cute little Eevee looking off into the distance amidst a white background. And if you were following along, you probably have something similar with the Pokemon of your choosing. Great job! Pat yourself on the back. All that's left to do now is make some small adjustments with the render settings in the outputted image, and we'll be good. To make these adjustments, let's go over to our render properties and look under Samplings. In short, samplings dictate how long Blender will take to calculate your image, so more samplings will equal higher quality renders at the cost of rendering time, and vice versa. I feel like 128 samples is quite a lot for a render like this, so I'm going to set it down to 45. Plus, there's a little trick we can use to help us get over some of the problems with low sampling after our image is rendered, so I'll be sure to show you that. But enough with the fancy talk, let's render our Pokemon image by going to Render and then pressing Render Image. This image will likely take longer to render for you than it will for me, but once it's all finished, you should end up with something like this. Now, if you take a closer look at Eevee, you may notice all of these little fuzzies on it. This is called noise, and it's the main bane for rendering with a low sample count. But this is where we'll pull out that super secret trick. Click back to previous to go back to our default workspace, and then click this tab here to enter the compositing workspace. Once here, enable Use Nodes, and this will give you two boxes, or nodes, to work with. One is our basic render layer, and the other is our final composite, or image output. Nodes will be something I will go into much more detail on in future tutorials, so I'll go through this part quickly. Separate these two boxes a bit, and then go to Add, Output, Viewer. Position this viewer node underneath the composite node, and connect the render layer's image pass to it. This will allow us to see a preview of our render while we're working on it. You can change the position of this preview render by going up to View. Adjusting the zoom value will zoom the image in and out, while pressing the move button will allow you to move the preview with your mouse. Next, press Shift A to bring up the node menu again, and go to Filter, and then select Denoise. Put this Denoise node over the line between the render layer and the composite node, and run another line from the Denoise node into the viewer node. Bam! The noise is gone, and Eevee's looking nice and happy. For good measure, I'm going to quickly enter the view layer properties, enable denoising data, and run some lines from these new dots on the render layer node into the denoise node. And with that, all that's left to do now is export your image. Go to the rendering workspace here, change the displayed image to the viewer node, go to Image, press Save As, choose a place to save your image, name your image, save your image, and you'll be actually, finally, 100% completely done. Congrats once again! You now have a really cool render that you can use for all sorts of things. Show it to your friends, make it your computer wallpaper. The choice is yours. If you followed this tutorial all the way to the end, I would love to see your finished work. So please feel free to @ me on Twitter or share your render in my Discord server. Also, if you have any questions regarding Pokemon models or this tutorial, or if you have any comments or criticisms with how this video was structured, then please leave a comment down below. I try my best to answer as many comments as possible, so there's a very good chance that I'll get back to you should you have something to say. From here on out, this video will mainly address some of the importing issues I mentioned near the beginning of the video, so if you're dealing with one of those, then stick around. Otherwise, thanks for watching. In our next tutorial, we'll be covering the textures on Pokemon models, and how they can be used to create shiny Pokemon and change facial expressions. So let's say you import your Pokemon model, and it starts off super big. Not only that, but the eyes and mouth are separated from the rest of the model, creating this weird crease look. You'll probably want to fix that, and luckily, it's pretty easy to do. Simply go to the Object Data Properties and open up the UV Maps tab. You'll see a map with a long name like this, and you'll want to rename this to something simple, like for instance, the Pokemon's name. Once you do that, highlight the name of your UV map and press Ctrl-C to copy the name to your clipboard. Once it's copied, select the other separated objects on your model, like the eyes and the mouth, and then paste your new name over each of their UV maps. The important thing is that the UV maps on each object share the same name. Once that's done, Shift-select all of the objects and press Ctrl-J to combine them into one object. This has to be done after renaming the UV maps, or else the textures on the model will get distorted. We still need to fix the creases though, so tab into Edit mode, press A to select all of your vertices, and go to Mesh, Merge, by Distance. That should flatten things out for you. All that's left to do now is grab the model's armature, shrink it down to an appropriate size, and apply the model's transforms by pressing Ctrl-A, All Transforms. Do this for the main model as well. From here, you're good to follow the main tutorial as normal. What about this? Not only is your model super huge, but its armature is turned completely sideways. Plus, there's these weird crosshair things everywhere. What is one to do? Well, I'll show you. First, you'll want to get rid of these weird crosshair things, which are formerly known as empties. You can either do this by selecting them manually in the viewport, or by selecting them up here in the outliner. Selecting one will select the other, so do whatever is easier for you. Once you have them selected, simply delete them. From here, it's just a matter of using the outliner to select and delete things you don't need. So for example, I don't want this random ambient light that was added to my scene with the model. So I'm going to select that here, go to the viewport, and delete it. Be on the lookout for things that look strange or out of place. For example, there's an armature here with the name Feeler A, and should we select it and move it around, nothing really happens. We probably don't need this, so I'll delete it. Among these objects, there's usually one empty that the model and the armature are parented to, and as such, affect the position of the model. So for example, moving this empty causes the model to shrink down to what would be its normal size, and follow the position of the empty around. While this empty may seem important, it's probably not something we're going to want to deal with forever, so it's best to just delete it and set the size down manually later. This will bring the model back to a weird position, but don't worry, we'll fix this in a moment. Let's just get rid of some of these extra empties first. We're now down to our main armature in the outliner, which with models that have this problem is usually called waist. From here, we can fix the positioning on our model. Select the Pokemon model, tab into Edit mode, and press A to select all of its vertices. Once you do that, go up here and set the Transform Pivot Point to 3D Cursor, which is currently resting in the center of our scene. Now press R, X, 90 in that order. This will rotate the model exactly 90 degrees on the X-axis, and line it up with our armature perfectly. Now just shrink the armature down and press Ctrl-A to apply all transforms. Like the last example, do this with the model too, just for good measure. You're done! Go to blender.org and download Blender. Go to the Models resource. Download a Pokemon model. Create a folder structure for your downloaded model. Open Blender. Delete Cube. File, Import, colladadefault.dae. Enable these 3 buttons. Import your models.dae file. Enter material shading. Enter material properties. Lower metallic value on your model's materials. Rename materials appropriately. Adjust specular and roughness values. Save! Open new window. Set new window to camera view. Adjust camera's position and focal length. Mess with the pixel resolution, if you want. Select the model's armature. Rename the model's armature. Enable in front in the armature viewport's display settings. Adjust bone display, if you want. Go into pose mode. Rotate the bones on your model to pose them. Be mindful of the small end and deformation bones resting at the end of some bone chains. Back to object mode. Add a plane and scale it. Enter edit mode. Extrude a new face out of the back of the plane. Enable edge select. Select edge. Control B and scroll wheel to bevel. Object mode. Set plane shading to smooth. Enabled render shading on your camera view. Enter the cycles render engine. Select the model. Edit mode. Press A to select all the faces. Tries to quads. Enable compare UVs immediately. Add subdivision surface modifier to your model. model. Move lamp to the left side of your scene. Mess around with the lamp settings. Disable strength value in the world properties. Duplicate lamp. Move lamp to the other side of your scene. Disable cast shadow. Lower lamp strength. Set samples and render properties. Render image. Back to previous. Enter the compositing workspace. Enable use nodes. Add viewer node. Run render layers image pass into viewer node. Add denoise node in between the render layer node and the other two nodes. Enter rendering workspace. Set image to viewer node. Save your image. Done.